Hello student, in the last video we see that to find out the terms in the geometric progression, show that the given sequence is in geometric progression and the examples depending on the geometric progression. Now in this video we will see how to find out the sum of the geometric progression and the examples depending on this sum formula. In the last year you learned the sum of the arithmetic progression. In the same way these examples are here. That is, we calculate the sum of all the terms. That is the formula. Sn is equals to a in bracket r raised to n minus 1 upon r minus 1, or Sn is equals to a in bracket 1 minus r raised to n upon 1 minus r. These two formulas depends on the value of r. Now the exam formula is very simple, but we'll see all the problems clearly of this exercise. I hope that you will understand all the problems. Now let us start. The sum of nth term of a geometric progression. It is denoted by S suffix n. Let T1 plus T2 plus T3 up to the Tn as the sign is for summation, where r is equals to 1 to n, T suffix r is equals to S suffix n. Means what? The sum of all the terms. Now this is theorem. If ar square up to ar raised to n minus 1 is a geometric progression, Sn is equals to a plus ar square plus dash dash plus a into r raised to n minus 1 Sn is equals to the sum of all the terms, that is a T1 plus T2 plus T3 up to the Tn. Then the S suffix n is equals to r raised to 1 to n T suffix r, and that is equals to a in bracket 1 minus r raised to n upon 1 minus r, where r is not equals to 0. Now in this case the value of the r is less than 1, therefore we are applying this formula, that is Sn is equals to a in bracket 1 minus r raised to n upon 1 minus r, where r is not equals to 1. Now the next. Note that if r is positive and the value of r is less than 1, it is convenient to write Sn is equals to a in bracket 1 minus r raised to n upon 1 minus r. Next, if r is positive and the value of r is greater than 1, it is convenient to write Sn is equals to a in bracket 1 a in bracket r raised to n minus 1 upon r minus 1. This is formula for the sum of the geometric progressions when we have the values of r which is less than 1 and greater than 1. If r is equals to 1, then GP is a up to the n times. Therefore, Sn is equals to a into n. This is the sum of the terms where r is equals to 1. Now we'll start the exercise 2.2. For the following GPs, find Sn. Now the first example, 3, 6, 12, 24. Now here see this, a is equals to 3 and the value of the geometric progression. A is equals to 3. I'm making small mistake there. That is a T2 upon T1, T3 upon T2. A is equals to 3. T2, that is a T1. T2 is equals to 6. T3 is equals to 12. R is equals to T2 upon T1, 6 upon 3, 12 upon 6, and the value is R is equals to 2. Now we find out the value of R is greater than 1. The value of R is greater than 1. Now, therefore, we apply the formula Sn is equals to a in bracket r raised to n minus 1 upon r minus 1. This is the formula throughout the exercise. You have to remember this. That is a 3 in bracket 2 raised to n minus 1 upon 2 minus 1. That is equals to 3 into in bracket 2 raised to n minus 1. This is the Sn. Therefore, Sn is equals to 3 in bracket 2 raised to n minus 1. Now, second example, p, comma q, comma p square upon q square upon p, q cube upon p, and in this way. Here T1 is p, T2 is q. Therefore, R is equals to T2 upon T1, that is a q upon p. Therefore, Sn is equals to a in bracket 1 minus r raised to n upon 1 minus r. The value of a is p, 1 minus the value of r is q upon p bracket raised to n upon 1 minus q upon p. Now simplify this. If p upon q is less than 1, now in this case simplify this. That is a p in square bracket 1 minus q upon p bracket raised to n, the divided by p minus q upon p. That is a p get cancelled, and that's why you are getting p into p, that is a p square upon p minus q in bracket 1 minus q upon p bracket raised to n. Also, if the value of q upon p is greater than 1, then it is a in bracket r raised to n minus 1 upon r minus 1. That is a p in bracket q upon p bracket raised to n minus 1 upon q upon p minus 1. Therefore, p in bracket q upon p bracket raised to n minus 1 upon q minus p upon p. Again by the multiplied and reciprocal, there become p square upon q minus p in bracket square bracket q upon p bracket raised to n minus 1. In this way, we have the formula for the Sn, where q upon p is a greater than 1, and the second is q, this is the second one, q upon p is a greater than 1. Now third, that is 0.7, 0.07, 0.007. Now see this, here T1 is equals to 0.7, therefore T2 upon T1 is equals to 0.07 upon 0.7, and that comes, that is multiplied and d by 100, then you will get 7 upon, that is equals to 7 upon 70, that is equals to 1 upon 10. Therefore R is equals to 1 upon 10, which is less than 1. Therefore Sn is equals to A in bracket 1 minus R raised to n upon 1 minus R. Substitute the values. The value of A is 0.7 in bracket 1 minus 1 upon 10 raised to n upon 1 minus 1 upon 10. Now simplify this. That is 0.7 in bracket 1 minus 0.1 bracket raised to n. 1 minus 1 upon 10 means what? 9 upon 10. Now simplify this. Multiplied and reciprocal 0.7 into 10 upon 9 in bracket square bracket 1 minus 0.1 bracket raised to n. Therefore it is 7 upon 9 in square bracket 1 minus 0.1 bracket raised to n. Therefore Sn is equals to 7 upon 9 in square bracket 1 minus 0.1 bracket raised to n. And hence answer is written in this manner also. That is 7 upon 9 in square bracket 1 minus 1 upon 10 bracket raised to n. This is the formula for the Sn. Now next, number 4, root 5 minus 5, 5 root 5 minus 25. Here the T1 is equals to root 5, T2 is equals to minus 5, T3 is equals to 5 root 5, and in this way we will find out the common ratio, which is T2 upon T1 minus 5 upon root 5, and that comes. Now this, I am writing this 5 as root 5 into root 5, which you learn in the 9th standard in 3rd chapter, that is the root 5 get cancelled. You are getting the value of R, that is equals to minus root 5, which is less than 1. Therefore Sn is equals to A in bracket 1 minus R raised to n upon 1 minus R. Now substitute the values. That is A is root 5, 1 minus in bracket minus root of 5 bracket raised to n upon 1 minus in bracket minus root 5. Now this is the root 5 upon 1 plus root 5 into in square bracket 1 minus in bracket minus root of 5 bracket raised to n. This is the Sn for the given sequence. Therefore 5 upon 1 plus root of 5 in next bracket 1 minus in bracket minus root of 5 bracket raised to n. Sometimes the answer from the textbook may be the different, but I had written this. You may agree or may not agree, but I had done it clearly. Next, question number 2. Here R is equals to minus 2 by 3, which is less than 1. Sn is equals to A in bracket 1 minus R raised to n upon 1 minus r. Now substitute the values. That is a 2 in bracket 1 minus 2 by 3 bracket raised to n upon 1 minus in bracket minus 2 by 3. Now simplifying this, you are getting the 2 in bracket in square bracket 1 minus 2 by 3 bracket raised to n upon 1 plus 2 by 3, and after simplifying you are getting 6 upon 5 1 minus in bracket minus 2 by 3 bracket raised to n. Normal simplification is there. You can understand this simplification. Therefore, Sn is equals to 6 by 5 in bracket square bracket 1 minus 2 by 3 bracket raised to n. Bracket raised to n must be there because we are finding the value of S6. Therefore, replace n by 6. Therefore, it is a 5 by 6 in square bracket 1 minus 64 upon 729. Now simplify this. It's a very simple. That is 1 into 729. That is 729 minus 64 upon 729. That is 6 by 5 into 665 upon 729. And normal simplification is there. Therefore, 266 upon 243. This is S6. That is a 266 upon 243. Now the next is, if S5 is 1023, R is equals to 4, find it. Now we have the formula. R is value of the R is greater than 1. Therefore, we will apply the formula. Sn is equals to A in bracket R is. Sn is equals to A in bracket R is to n minus 1 upon R minus 1. Substitute the value of R. That is S5 is equals to A. 4 is to 5 minus 1 upon 4 minus 1. Therefore, 1023 is equals to A. 4 is to 5 minus 1. 4 minus 1 is 3. And therefore, 1023 into 3 is equals to A. 4 is to 5 means what? 1024 minus 1. Therefore, after simplifying you are getting, that is A is equals to 1023 into 3 upon 1023, that get cancelled. Therefore, the value of A is equals to 3. Now the next is, for GP, A is equals to 2, R is equals to 3, Sn is equals to 242. Find n. Now see this here. Sn is equals to A in bracket R is to n minus 1 upon R minus 1. Therefore, the value of A is 2. R is 3 raised to n minus 1 upon 3 minus 1, and that comes. Therefore, 242 is equals to 2 in bracket 3 raised to n minus 1. That 2 get cancelled. Therefore, you are getting 242 is equals to 3 raised to n minus 1. And that's why 3 raised to n is equals to 242 plus 1. That is a 243, which is 3 raised to 5. Therefore, n is equals to 5 here. N is equals to 5. Next, for a GP, sum of the first 3 terms is 125 and the sum of the next 3 terms is a 27. Then find the value of R. Now this is, that is S3 is equals to 125. Next, S6 is equals to 125 plus 27. Therefore, it becomes 152. Now here Sn is equals to A in bracket 1 minus R raised to n upon 1 minus R. Therefore, S6 is equals to A in bracket 1 minus R raised to 6 upon 1 minus R. Therefore, the value of A, that is equals to 152. And Sn is equals to A in bracket 1 minus R raised to 3 upon 1 minus R. If you take their ratios, then you will get S6 upon S3, A in bracket 1 minus R raised to 6 upon 1 minus R, whole divided by A in bracket 1 minus R cube upon 1 minus R. 1 minus R get cancelled, and you are getting the 1 minus R raised to 6 upon 1 minus R raised to 3, and that is equals to 152 upon 125. Now, a split of this, 1 minus R raised to 6 can be written as 1 minus R raised to 3 in first bracket and in second bracket. That is using the formula A square minus B square. Therefore, that is 152 upon 125. Therefore, in first bracket, we are getting 1 minus R cube into second bracket 1 plus R cube upon 1 minus R cube is equals to 152 upon 125. That is 1 minus R cube to the numerator and denominator get cancelled. Therefore, we are getting 1 plus R raised to 3 is equals to 152 upon 125. Therefore, R cube is equals to 152 upon 125 minus 1. Now simplify this. That is a 152 minus 125, that is a 27 upon 125. Therefore, take the cube root on both sides. Therefore, R is equals to 3 upon 5. R is equals to 3 upon 5. Hence, R is equals to 3 upon 5. For a GP, if T3 is equals to 20, T6 is equals to 160, then find the Sn. Now apply the formula for the Tn for the geometric progression. Here Tn is equals to A into R raised to n minus 1. Therefore T3 is equals to A R raised to 3 minus 1. It is AR square is equals to 20. Therefore AR square is equals to 20. At the same time we find out the T6. T6 is equals to A into R raised to 6 minus 1, and that is equals to A into R raised to 5, that is equals to 160, and therefore T6 upon T3 is equals to AR raised to 5 upon AR square, that is a 160 upon 20. That's A get cancelled, therefore we are getting the 8. That is R raised to 5 upon R square, that is R raised to 3 is equals to 8, that is a 2 raised to 3. Therefore, the value of R is equals to 2. Value of R is equals to 2. I am correcting it. R is equals to 2 here. Now next is AR square is equals to 20. Substitute the value of R, that is a 2. That is A into 2 raised to 2 is equals to 20. Therefore A into 4 is equals to 20. Therefore A is equals to 20 upon 4. Therefore A is equals to 5. Now the next is, therefore S7 is equals to, that is a Sn is equals to A in bracket 1 minus, that is R, because the value of the R is a greater than 1. Therefore Sn is equals to A in bracket R raised to n minus 1 upon R minus 1. Therefore S7 is equals to 5 in bracket 2 raised to n minus 1 upon 2 minus 1. Now simplify this. S7 is equals to 5. 2 raised to 7 means what? 128 minus 1 upon 2 minus 1 is 1. Therefore 5 into 127, and that's multiplication is 635. Therefore S7 is equals to 635. Now the next is T4 is equals to 16, T9 is equals to 512, and then find S10 in the same manner. Tn is equals to A into R raised to n minus 1. Therefore T4 is equals to A into R raised to 4 minus 1, that is AR cube is equals to 16. Now next is also T9 is equals to A into R raised to 9 minus 1, that is A into R raised to 8, that is 512. A into R raised to 8 upon AR cube, that is 512 upon 16. Now here R raised to 5, and that comes the value of R is equals to again 2. Now next, also AR raised to 3 is equals to 16. Now substitute the value of R, that is a 2 raised to 3, that is equals to 16. 2 raised to 3 means what? 8 is equals to 16. Therefore A is equals to 16 upon 8, that is equals to 2. A is equals to 2. Next is, now Sn is equals to A in bracket R raised to n minus 1 upon R minus 1. Therefore S10 is equals to 2 in bracket R raised to 10 minus 1 upon R minus 1. Therefore 2 in bracket 2 raised to 10 minus 1 upon 1, and that is a 2 in bracket 2 raised to 10, that is a 2023, or we will substitute the value of 2, that is the value of the 2 raised to 10, that is a 1024 minus 1, and their multiplication now, that is 1023 into 2, that is a 2046. Therefore S10 is equals to 2046. Now the next problem number 5. Find sum to the n terms. Now the first is 3 plus 33 plus 333 plus 3333, and in this way, that is 3 plus 33 plus 333 plus 3333 up to the n terms. Now if we take 3 as common, then we will get, that is a 3 in bracket 1, 11, 111, 1111 up to the n terms. Now divide and multiply numerator and denominator by multiplying n and d by 9. Therefore we will get, that is a 3 upon 9 into 9 in bracket 1 plus 11 plus 111 and dash up to the n terms. After their multiplication, that is a 3 upon 9 in bracket, you are getting 9 plus 99 plus 999 up to the n terms. Now here 3 upon 9, this is in the geometric progression. Now we can write it like this, that's a 10 minus 1 plus 100 minus 1. 999 can be written as 1000 minus 1, and in this way up to the n terms. Now we will separate this, that is a 3 upon 9 in which is written as 1 upon 3. Now 10 plus 100 plus 1000 dash dash, this is in the first bracket, and the second bracket you will get minus in bracket 1 plus up to the n terms. Therefore 1 upon 3 10 in bracket 10 raised to n minus 1 upon 10 minus 1. Again, this is in the geometric progression. The first term is a and the common ratio is a 10, and 1 plus 1 plus 1 plus up to this. The sum of the all 1 up to n is 1 into n means what, n. Now next is, that is 1 by 3. That is a 10 in bracket 10 raised to n minus 1. 10 minus 1 is 9 minus n. Now normal simplification is there. 10 in bracket 10 raised to n minus 1 upon minus 9n upon 9, that is equals to 1 upon 27 in bracket 10 raised to n minus 1 minus 9n, 9n must be there, that is 1 upon 27 10 raised to 10 into 10 raised to n minus 1. I am correcting here, that is a 9n, 10 in bracket 10 raised to n minus 1 minus 9n, that is again multiplied n and d by 3 upon 89. That is answer from the textbook. It is written in this manner, that is 3 upon 81 in bracket 10 into in bracket 10 raised to n minus 1 minus 9n, bracket complete. Now next is 8 plus 88 plus 888 plus 8888. These are the terms. Take 8 as common, then in bracket you will get 1 plus 11 plus 111 dash dash up to the n terms, and therefore again multiplied n and d by 9, then in square bracket 1 plus 11 plus 111 up to the n terms. After multiplying, you are getting the 8 upon 9, that is a 9 plus 99 plus 999 up to the n terms. Therefore, now this 9 can be written as 10 minus 1. Same type of the problem is there. 99 can be written as 100 minus 1, 1000 minus 1, and in this way up to the n terms. That is equals to 8 upon 9 in bracket 10 plus 100 plus 1000 plus dash dash up to the n terms, up to the n term. Now I am writing here up to the n terms, and in second bracket minus in bracket 1 plus up to the n terms, up to the n terms. That is equals to 8 upon 9 in bracket. Now again this is in the geometric progression. It is written in this fashion, that is that 10 plus 10 square plus 10 raised to 3 up to the dash dash up to the n terms minus 1 plus 1 up to the n terms. Now 10 plus 10 square plus 10 cube, it is in geometric progression. A is equals to 10, R is equals to also 10. Therefore 8 upon 9 in bracket 10 in bracket 10 raised to n minus 1 upon 10 minus 1, and the sum of the all the 1 up to the n, that is 1 into n is n. Therefore 8 upon 9, 10 in bracket 10 raised to n minus 1 upon 9 minus n, and that is 8 upon 9 in bracket 10 raised to n minus 1 minus 9n upon 9, again 9 into 9 which is 81, that is 8 upon 81 in bracket 10 in bracket 10 raised to n minus 1 minus 9n. Therefore Sn is equals to 8 upon 81, 10 in bracket 10 raised to n minus 1 minus 9n. This is the answer. Now next, find the sum of the nth term, that is 0.4 plus 0.44 plus 0.444 up to the n terms. Now from all these terms, we will take 4 as common, then 4 in square bracket 0.1 plus 0.11 plus 0.111 up to the n terms. Now again multiply numerator and the denominator by the 9. Therefore it becomes 4 upon 9. 0.9 into 9, that is 0.9. 0.11 into again 9, that is 0.99, and in this way it is written 4 upon 9 in bracket. 0.9 means what? 1 minus 0.1. 0.99 means what? 1 minus 0.01. And 0.999 means what? 1 minus 0.001 up to the n terms. That is 4 upon 9. That is 1 plus 1 plus 1 up to the n terms. Minus in bracket. Minus in bracket 0.1 plus 0.01 plus 0.001 up to the n terms. Sequence and series, these are the complicated chapters for the calculations. Therefore, you have to do more and more study for here. Now see this 1 plus 1 plus 1 up to the n terms means what? 1 is repeated n times, and that is their sum is nothing but 1 into n. Therefore, it is written as n minus. Now see this 0.1 means what? 1 upon 10. 0.01 means what? 1 upon 10 square. 0.001 means what? 1 upon 10 cube. Up to the n terms. Now see this 4 upon 9 in bracket n minus. Again this is in the geometric progression. Here a is equals to 1 upon 10. R is equals to also 1 upon 10. And the value of the r is less than 1. Therefore the formula is a in bracket 1 minus r is to n upon 1 minus r upon 1 minus 1 upon 10. Now simplify this. That is a is equals to 1 upon 10, r is equals to also 1 upon 10. That is a 4 upon 9 in bracket n, 1 upon 10 in bracket 1 minus 1 upon 10 raised to n. 1 minus 1 upon 10 is 9 by 10. That is a 4 upon 9, that is n. 10 get cancelled and you are getting the 1 upon 9 in bracket 1 minus 1 upon 10 raised to n. Now next, that is equals to 4 upon 9 take the 9 as common, then you will get 9n minus in bracket 1 minus 1 upon 10 raised to n, bracket complete. Therefore 4 upon 81 in bracket 9n minus, it is written in this manner, 1 minus 0.1 bracket raised to n, or you may write in any manner, that is a 4 upon 81 in curly bracket 9n minus in square bracket 1 minus 0.1 bracket raised to n, bracket complete. That is equals to 4 upon 81 9n minus in square bracket 1 minus 0.1 bracket raised to n, that bracket complete. That is equals to 4 upon 81 9n minus in normal bracket 1 minus 0.1 minus 1 upon 10 raised to n, bracket complete. Someone say that in the textbook last given answer is like this and your answer is like this. Therefore I had written in the both way. Now next is, now again next find out the sum of the terms, that is a 0.7 plus 0.77 plus 0.777 up to the n terms. Take 7 as common, then in bracket you will get, that is 0.1 plus 0.11 plus 0.111 up to the n terms. Again multiplied n and d by, therefore we will get, that is 7 upon 9 in bracket 0.9 plus 0.99 plus 0.999 up to the n terms. And the sequence and series, this chapter, in this chapter there is too much calculations are there. That is equals to 7 upon 9 and 0.9 can be written as 1 minus 0.1 plus 1 minus 0.01 plus 1 minus 0.001 up to the n terms, and it is written in this manner, that is 1 plus 1 plus 1 plus up to the n terms minus 0.1 plus 0.01 plus 0.001 up to the n terms. Therefore 1 plus 1 plus 1 up to the n terms means what? 1 into n, that is n, minus 0.1 means what? 1 upon 10. 0.01 means what? 1 upon 10 square. 0.001 means what? 1 upon 10 raised to 3 up to the n terms. That is 7 upon 9 in square bracket n minus again the bracket term, that is 1 upon 10, 1 upon 10 square, 1 upon 10 raised to 3. This is in GP. Here A is equals to 1 upon 10. R is equals to also 1 upon 10. Therefore, what is the formula? A in bracket 1 minus R raised to n upon 1 minus R, that is 1 upon 10 in bracket 1 minus 10 raised to n upon 1 minus 10. 1 minus 1 upon 10. Therefore, here I am writing the values, that is A is equals to 1 upon 10, R is equals to 1 upon 10. Now simplify this, that is 7 upon 9 in square bracket n minus 1 upon 10 in bracket 1 minus 1 upon 10 raised to n whole divided by 9 upon 10, that is 7 upon 9. Now multiplied 9n in bracket n minus in bracket 1 minus 1 upon 10 raised to 9 upon 9, and simplify this. Therefore, we will get 7 upon 81 9n minus in bracket 1 minus 10 raised to n, that is 7 upon 81 9n minus in bracket 1 minus 10 raised to n. This is the sum. Now next is 0.5, 0.05, 0.005. Here A is equals to 0.5 and R is equals to 0.05 upon 0.5, and that is equals to 0.1, which is equals to 1 upon 10. Now to find out the value of that R, multiply n and dy, that is 100, then you will get R is equals to 1 upon 10. R is equals to 1 upon 10. Here R is less than 1, therefore we will apply the formula Sn is equals to A in bracket 1 minus R raised to n upon 1 minus R. The value of R is 0.5 in square bracket 1 minus 1 upon 10 raised to n upon 1 minus 1 upon 10. Now simplify this, 0.5 1 minus 1 upon 10 raised to n, that is a 9 upon 10, and that is 0.9 into 10 upon 9, that is 1 minus 1 upon 10 raised to n, 9 upon 10. Now multiply and reciprocal, 0.5 into 10 upon 9 in bracket 1 minus 1 upon 10 raised to n, that is 5 upon 9 in bracket 1 minus 10 raised to n, bracket complete. Hence 5 upon 9 in bracket 1 minus 1 upon 10 raised to n is equals to, this is the Sn. Now next is 0.2, 0.02, 0.002, and in this way up to the n terms. A is equals to 0.2, R is equals to 0.02 upon 0.2, that is R is equals to 1 upon 10, A is equals to 0.2. Now see this, Sn is equals to A in bracket 1 minus R raised to n upon 1 minus R. Now simplify this, A is 0.2, 1 minus 1 upon 10 bracket raised to n, that is 1 upon 10 raised to n, in bracket 1 minus 1 upon 10. Now simplify this, that is 0.2 in bracket 1 minus 1 upon 10 raised to n, that is a 9 upon 10, and that comes 0.2 into 10 upon 9. Now see this 0.2 into 10 in bracket 1 minus 1 upon 10 raised to n whole divided by 9. Now normal simplification is there. That is 0.2 into 10 means what? 2 upon 9 in bracket 1 minus 10 raised to n. Therefore Sn is equals to 2 upon 9 in bracket 1 minus 1 upon 10 raised to n. Now for the problem, for a sequence, if Sn is equals to 2 in bracket 3 raised to n minus 1, find nth term. Hence, show that the sequence S is in a GP. Now this is very simple. We also formula for the 10 standard, that is the Tn is equals to Sn minus 1. Therefore, we will find out the terms values, that is Sn is equals to 2 3 raised to n minus 1, Sn minus 1, that is n is replaced by n minus 1 and their subtraction. Now from these two terms take 2 as common, then in bracket you will get 3 raised to n minus 1 minus 3 raised to n minus 1 plus 1. Minus 1 plus 1 get cancelled. Therefore 2 in bracket 3 raised to n. Now 3 raised to n can be written as 3 into 3 raised to n minus 1. Take 3 raised to n minus 1 as a common. Then in bracket you will get 3 minus 1, which is 2. That is 2 into 3 raised to n minus 1 into 2. And overall you are getting the 4 into 3 raised to n minus 1. This is your Tn. Therefore, this is the Tn. Next is now Tn plus 1, that is n is replaced by n plus 1, that is a 4 into 3 raised to n plus 1 minus 1, that is equals to 4 into 3 raised to n. Therefore Tn plus 1 upon Tn is equals to 4 into 3 raised to n upon 4 into 3 raised to n minus 1. Now 4 get cancelled. Therefore by using the law of indices we can solve this. 3 raised to n minus in bracket n minus 1, that is plus n minus n get cancelled. You are getting the 3. Tn plus 1 upon Tn is equals to 3, which is constant, and hence the series is in geometric progression. Given sequence is in geometric progression. R is equals to 3. Now here S is sum, P is a product, R is a reciprocal of the geometric series. Let A be the first term, R be the common ratio. Now here A be the first term, R be the common ratio of GP. Then S is equals to A in bracket R raised to n minus 1 upon R minus 1. This is the formula for the sum. Now next is now the terms of GP are A, AR, AR square, AR raised to 3, AR raised to n minus 1. Then their products, that is A into AR square into AR cube up to the AR raised to n minus 1. Now multiplication, that is A is repeated n times, therefore it becomes A raised to n, and R into R square into R cube up to the R raised to n minus 1. Now see this, that is a raised to n r raised to 1 plus 2 plus 3 plus up to the dash dash n minus 1. Now consider this, that is 1 plus 2 plus 3 up to the n minus 1. This is in arithmetic progression. Here a is equals to 1, d is equals to 1, and therefore this is in AP, that is a is equals to 1, d is equals to 1, therefore sum of AP is equals to n upon 2 in bracket 2a plus n minus 1 into d. This is the formula in the 10th standard. In the same way here, n minus 1 upon 2, 2a, a is 1 plus n minus 1 into d, that is n minus 1 into d means what? Common difference is 1. Now simplify this. That is, I had written the formula for the Sn. Sn is equals to n upon 2 in bracket 2a plus n minus 1 into d. Therefore, we have that is n upon 2, n minus 1 upon 2 in bracket 2 plus n minus 1. That is a plus 2 minus 2 get cancelled, n into n minus 1 upon 2. Therefore, this is the product, and it comes, that is a raised to n into r raised to n in bracket n minus 1 upon 2. This is the product. And next is reciprocals of the terms. Now see this interesting example, interesting derivation this is, though it is complicated. That is 1 upon r plus 1 upon ar plus 1 upon ar square reciprocal terms and their sum, that is a 1 upon ar square plus dash dash up to the 1 upon a into r raised to n minus 1. Therefore, from this term, we will take a as 1 upon a as common. Then in bracket, you will get 1 plus 1 upon r plus 1 upon r square up to the 1 upon r raised to n minus 1, bracket complete. Therefore, 1 upon a in bracket, this is in the geometric progression again, and it is written in this manner, that is a r raised to n minus 1 upon r raised to n minus 1. Now what is here? That is 1 is multiplied to the numerator, 1 is written as 1 upon 1, and to the 1 he multiplied r raised to n minus 1 upon 1 into r raised to n minus 1. For the second term, 1 upon r he also multiplied, that is a r raised to n minus 2. Then and then he get to the denominator r raised to n minus 1. Means what? 1 upon r is multiplied n and d by r raised to n minus 2. What about 1 upon r square? In the same way, 1 upon r square to the numerator and denominator is multiplied by 1 upon r raised to n minus 3. And in this way, we are getting to the denominator all the terms r raised to n minus 1. Therefore, now see this, r raised to n minus 1 plus r raised to n minus 2 plus r raised to n minus 3 plus dash dash plus 1, and this is written as 1 plus r square plus dash dash r raised to n minus 1. This is GP, a is equals to 1, common ratio is r, Therefore, sum of the n term is 1 minus r raised to n minus 1 upon r minus 1, and it is written as r raised to n minus 1 upon r minus 1. Therefore, the sum of the reciprocals, that is equals to r raised to n minus 1 upon a into r raised to n minus 1. Therefore, capital R is equals to r raised to n minus 1 upon r minus 1 into a r raised to n minus 1. Therefore, now see this, S means sum, R is reciprocal, bracket raised to n. Now the starting sum, this is S. Now substitute the value of S, A into r raised to n minus 1 upon r minus 1. This is S. And the reciprocal, that is just we have find out it. That is a 1 upon r raised to n minus 1 whole divided by r minus 1 into a r raised to n minus 1. Bracket complete. And therefore, whole bracket raised to n. A r raised to n minus 1 upon r minus 1 into r minus 1 into a r raised to n minus 1, that become multiplied and reciprocal whole divided by r raised to n minus 1 and bracket raised to n. Therefore, r minus 1 get cancelled, and r raised to n minus 1 to the numerator and denominator also get cancelled. A into a becomes a square into r raised to n minus 1 and whole bracket raised to n. Therefore, this is a raised to 2n into r raised to 2n minus 2. R raised to, that is r raised to n into n minus 1. A raised to 2n into r raised to n in bracket n minus 1. Now, this is the, again this can be written as in this manner, that a raised to n into r raised to n into n minus 1 upon 2 bracket square, and that is nothing but the p, that is the product of the terms, and hence p square is equals to s upon r bracket raised to n is proved. Is simple adjustment of the terms is there. Question number 10. If Sn, S2n, S3n are the sum of the nth, 2n, 3n terms of the GP respectively, if Sn, S2n, S3n are the sum of the n, 2n, 3n terms of a GP respectively, then verify that Sn in bracket S3n minus S2n is equals to S in bracket S2n minus Sn bracket square. Let A be the first term. Let A be the first term. R is the common ratio of the GP. Therefore, Sn is equals to by using the regular formula, A in bracket r raised to n minus 1 upon r minus 1. Now next is S2n is equals to A into r raised to 2n minus 1 upon r raised to 2n minus 1 upon r minus 1 and S3n is equals to A into r raised to 3n minus 1 upon r minus 1. Now see this, Therefore, S2n minus Sn is equals to A in bracket r raised to 2n minus 1 upon r minus 1 minus Sn A into r raised to n minus 1 upon r minus 1. From these two terms, take the A upon r minus 1 as a common. Then in bracket you will get r raised to 2n minus 1 minus r raised to n plus 1. Minus 1 and plus 1 get cancelled. Then in bracket you will get A upon r minus 1 r raised to 2n minus r raised to n. Therefore, A into r raised to n take as common. Then in bracket r raised to n minus 1 upon r minus 1. Therefore, S2n minus Sn is equals to S2n minus Sn bracket square is equals to A into r raised to n minus r raised to n minus 1 upon r minus 1 whole bracket square is equals to A raised to 2 r raised to 2n r raised to n minus 1 bracket square upon r minus 1 bracket square, and that is equals to A into r raised to n minus 1 upon r minus 1 take as a common. Then in bracket A into r raised to 2n in bracket r raised to n minus 1 upon r minus 1, and this is nothing but the Sn, and the value of A upon r minus 1. Now see this is also interesting how it is written. A upon r minus 1, r raised to 2n is multiplied in the bracket r raised to n minus 1. Therefore, it becomes r raised to 3n minus r raised to 2n. Now again A upon Sn in bracket A upon r minus 1 in bracket. Now see this, how the terms are arranged here. R raised to 3n minus 1 minus in bracket r raised to 2n minus 1 bracket complete. That minus 1 is adjusted there. That minus 1 and plus 1 becomes 0. That's why we are adjusting the terms Sn in bracket A into r raised to 3n minus 1 upon r minus 1. Again multiplied these two terms with A upon r minus 1. Therefore, it becomes A into r raised to 3n minus 1 upon r minus 1 minus A into r raised to 2n minus 1 upon r minus 1. And these terms are nothing but Sn in bracket S3n minus S2n, and hence our LHS is equals to the RHS is proved here. Again, the adjustment of these different terms, this type of the examples asked in the examination, 4 to 5 marks, because in this type of examples too much calculations are there, too much concentration is there. Therefore, S2n minus Sn bracket square is equals to Sn minus bracket square is equals to Sn in bracket S of 3n minus S of 2n, and hence it is proved. Now the next, this is very simple example. Find r is summation r is equals to 1 to n 3 into r raised to 3 into 2 raised to r. Now 3 is a constant, therefore we can take to the outside. That is 3 into summation r is equals to 1 to 10 2 raised to r. Now take the value of r as 1, 2, 3, and in this way you will get the geometric progression. That is a 3 in bracket 2 plus 2 square plus 2 raised to 3 plus dash dash up to the 2 raised to 10. And here a is equals to 2 and r is equals to also 2. Therefore, we will apply the sum formula for this series sequence. The value of r is 2. Therefore, 3 in bracket a in bracket r raised to 10 minus 1 upon r minus 1. Therefore 3 in bracket, the value of A is 2, R is to 10, means 2 raised to 10 minus 1 upon 2 minus 1, and that's why you are getting, that is 3 into 2, that is a 6, 2 raised to 10 minus 1, that is a 2 raised to 10 means what? 1024 minus 1, that is a 6 into 1023, and therefore the answer is 6138, 6138. Therefore the summation R is equals to 1 to 10, 3 into 2 raised to R is equals to 6138. Now next is summation R is equals to 1 to 10, 5 into 3 raised to R. Again 5 is a constant. Therefore again it is R is equals to 1 to 10, 3 raised to R. Again in the bracket you will get 3 plus 3 square plus 3 raised to 3 and dash dash up to the 3 raised to 10. Again here A is equals to 3, R is equals to also 3. Again it is in the geometric progression, and therefore their sum is written as in this manner: A is equals to 3, R is equals to also 3. Therefore 5 in bracket, 3 in bracket, 3 raised to 10 minus 1 upon 3 minus 1, bracket complete. That is a 5 into 3 upon 2, 3 raised to 10 minus 1, that is a 15 upon 2, 3 raised to 10 minus 1. Therefore summation R is equals to 1 to 10, 5 into 3 raised to R is equals to 15 upon 2, 3 raised to 10 minus 1. This is the answer. Now the next, the value of house appreciate 5% per year. How much is the house worth after 6 years if its current worth is rupees 15 lakhs? Given that is some values are given. The values of house appreciate 5% per year. Therefore new value for the first year is 15 lakh into 105 upon 100, that is equals to that is the total worth after 6 years is equals to 15 lakhs into 100 and in bracket 105 upon 100 bracket raised to 6. Now simple multiplication, that is in bracket 1.34 bracket raised to 6 is 105 upon 100 raised to 6. Its value is 1.34. Now their multiplication is 20 lakhs and 10,000. Its value is already given, therefore we have to substitute. That is 20.1 lakh. Hence the worth after 6 years is 20.1 lakh. That is this is the value. In this way, we have completed the second exercise, which is 2.2. It's again very complicated calculations are there. You have to do the more and more practice. Now we'll see in the next video. Till then, goodbye. In this way, we have completed the exercise 2.2. Only last example is remaining due to the time limit. I will take that example in the next video. I hope that you had understand all the problems given in this video. Now, if you are new for this channel, then subscribe it and share it with your needy friends. Now we'll see in the next video. Till then, goodbye.